Okay, so in this video, what I wanted to be able to do is touch base and explore some of the more complicated aspects or challenging concepts to grasp from last week's lab. I saw a lot of great conversation and a lot of engaging in the content, so that's awesome. I saw a lot of you trying to explore different ideas and concepts. But again, as you're going through these lab activities, try to keep in mind that all the questions I ask are going to be related to the lab activities you did. So somewhere in there, you're going to have the information that you need, or a concept or idea that I'm hoping to see you explore in the lab discussions. I know a lot of hypotheses came up last week, and some of them were right, and some of them were a little off the mark, but ultimately, to help you frame where you might want to be exploring will be from the lab itself, and so the lab manual will be a great resource. I'm just asking for some next step thinking typically when it comes to these lab discussions. So I wanted to briefly touch on standardized norms first. A lot of you brought up a lot of great challenging questions as far as why standardized norms aren't good for elite athletes. Standardized norms aren't great for women when you have to do a modified push-up, even though you can do from the toe push-ups. And so I just wanted to touch on base with that. First and foremost, I want to again say great job at being critical and exploring ideas, because this is what learning is all about. And in particular, the value that can come from discussions and putting an idea out there and then discussing its merits. So it can be a little scary, especially with your teacher hovering around on the forum and stuff like that, but and your peers and people that might have had a few more years in the area of study than you, but again, this is kind of what the process is about. And so I want to say thanks to all of you that are brave and putting answers out there, say earlier in the week than later, but also just being brave in the learning environment in general and putting thoughts out there and challenging ideas. So really, again, wheeling back around to standardized norms. Standardized norms are just that, standardized. So they're based off of a particular group. In this particular instance, because it's a standardized norm for a fitness test for the general population, we're really looking at everyone, all adults. So what does that mean? Well, you can look at your CSEP guideline or table, and you'll see that it's from 19 to 60 plus year olds. So usually when you're talking about an adult population, you're talking about 19 to 65, but again can include some others. So if we chat about specifically let's say the elite athletes and that concept, you're right. So again, how does standardized norms come from? Well, this goes back to the concept of standardized population curve, bell curve, and standard deviation, right? So if we have our population, we know for each age group and each gender, we're going to get something that kind of looks like this, right? So when we have a standardized norm, and again, this will be, let's say, number of people, and this will be number of push-ups, right? So this could be like, let's say 0, and let's say 100, okay? So in a minute, push-ups, we have this. We know from this, and from what you all know from standardized norms, research, and population data, this is generally what we get. So what you're seeing when you're looking at your charts are essentially the stratification of this into categories, right? And again, within certain deviations of this information, there's going to be different criteria. So I have more than your table has for criteria, but here this is very poor, this is poor, this is needs improvement, this is average or good. Okay, this is above average. This is good, and this is excellent, okay? And so you can see very quickly, you're like, if you're looking at a young, fit population, those of you engaged in athletics regularly, this is a kinesiology class, so we're already getting selection bias in the sense that those of you that have interest in human health and movement are probably also healthy and move a lot yourselves. So already we're selecting a group of you that are typically going to be probably in the upper half. Now, if you weren't in the upper half and in this class, that's fine. That doesn't say anything about you as a person. But performance-wise, we're looking here. Yeah, of course, most of you are going to be in a fairly good category, and especially the ones that we choose to post about ourselves are going to inherently be better typically for most people. So again, this is why, say, if we have a group of elite athletes, yeah, most of them are going to be in the excellent range. So what we can do then, say if you're specifically working with a group of, provincial level, national level athletes, whether they're adolescents or adults, is we find a sport specific at a national level standardization. So what we can do is we can essentially take our good and excellent athletes and we can say, okay, now these are actually, let's say 20 to 25-year-old soccer players, okay? And we can look at those, and if you happen to be in that category, we can have a whole new criteria, a whole new standardized norm that we compare you to, okay? And so your numbers probably start more at 50 or 20 or whatever to 150, let's say. Maybe push-ups is a little exaggeratory at 150, but just for example here, same thing. So within those elite athletes, you're going to get another standardized norm, bell curve of sorts, if you have a large enough sample size, and you can make categories out of this. And so you can be an elite soccer player who, compared to a nationalized or national level norms of elite soccer players, you're actually in the very poor category. Okay? And obviously it can be in, say, an excellent. Okay? So hopefully that helps understanding that a little bit. Now to go one step farther on that, with women and standardized norms and the modified push-ups. And so if you didn't read my post when I brought that up, I think it's quite dated language to call them girl push-ups. So that's why I haven't used that anywhere. But in a modified push-up, the reason women have that is if you think now, if you're looking at your norm for push-ups here for women across all age groups, because it has to be standardized, you can start thinking, can 50, 60-year-old women do more than one push-up to actually get onto a scale? Well, probably not from toes, but if you look from knees, yeah, modified push-ups for sure. Someone who is just maybe in a poor or needs improvement category can do just one push-up from knees. A woman in that situation at that age category. So again, yeah, and some of you figured that out and thought of that appropriately and said, oh, well, it's not just us as very fit young women. It's you got to look at across all women of all fitness levels, right? And so to be able to register some sort of number, that's why it's set up this way. Now, that being said, if the trend was women got into strength training, let's say, and in particular there was maybe a societal or cultural push to encourage women to have upper body strength, maybe sports such as climbing or something, bouldering became very popular through a large scale of the population. As cohorts of women entered new decades farther into life, yeah, maybe you'd have to go back and standardize the norms and be like, hey, look, for whatever reason now, 40, 50 years down the road from now, women are also scoring, always in the good and excellent category. So now this is an average, this is the average. So you'll have to re-standardize the norms. And that typically doesn't happen And if changes to standardization happens, it's usually, unfortunately, in the opposite direction. So standardized norms get easier to achieve. You can see this with military entry requirements too. Over the past, like since World War II, the standards have decreased over time to encourage or allow more participants in their testing to actually make it into the military. And so again, we know this too from health data that we've looked at in other classes, perhaps in particular with kinesiology, is obesity rates are going up, chronic health disease is going up, so and physical activity levels are going down. So because of that, when we look to re-standardize norms, we aren't necessarily looking to make them more challenging now and into the future. They're probably going to get easier. Again, hopefully if all of you get out into the world and change the world with your influence as kinesiologists, great. Hopefully that'll happen and it'll be a much happier, healthier place. Until then, this is kind of the state of the world currently. Okay, so hopefully that makes sense as far as standardized norms and why we have them. The next topic we'll touch on is the external rotation exercise. Sure, good enough. Okay. And so this one was really tricky too, and I picked it because it was the most challenging one, and it has a little trick in there relative to all the other exercises that you're supposed to cover in your lab. And the reason for that is I wanted you to explore this idea. If you understood it, you'll get the other stuff, okay? And so I wanted to see that kind of exploration, figuring this out. Ideally, you would have reached out to some of your peers, hopefully in your group, to kind of help understand this topic a bit more, because it was tricky. It was meant to be a challenge, okay? Again, lots of good ideas here. Some were quite good and on the ball. Some were a little bit off track, but great hypothesis. I think the thing I appreciated most in your posts typically were I could understand and see where your line of thought was. And again, this goes back to when I was saying you don't have to be right on your initial post. I'd rather see a learning process occur than say waiting till the last second or trying to see someone else's answer and just posting that, so if I see this learning process occurring where you're engaging in discussion and you're connecting the dots over the week, that's fine. You're definitely not losing marks there. If anything, you probably gain marks to see that process. But again, if you're able to connect the dots on your own, great, do that, post it, that's great as well, okay? So yeah, specifically, external rotation. I really should have prepared, I think, with dumbbells, but I'll use some markers here instead. So the image, and I some of you misinterpreted the image a little bit, and that's okay. So just to start off, again, the idea was the person was standing here with dumbbells. I'll try to act like they're heavy. Dumbbells, rotated out, internally rotated, okay? And I think that if you got off on the wrong foot right away, that was a tough go, okay? So one of the features that I wanted to point out here right from the top is during these actions and these movements and this lab in particular, because you're gonna have questions like this now on the final, whatever, so it's good to understand this. Do the action, like physically move and do it. You're in the safety of your own home. There's not anyone else in class that's going to watch you doing this in the middle of an exam, okay? So, knock yourself out. Go wild with it, okay? But yeah, again, so when you're doing this, trying to figure out, it helps to try to isolate what is moving, what is not, and then when you're analyzing each individual joint, say in this, for example, we've identified, okay, what's moving? No, it's not. My hands are moving in and out, but it's not my elbow because my elbow stays at the same angle the whole time, whether I'm bending in or out. It's my shoulder. My shoulder is doing internal and external rotation. Okay, that's the joint. So now that I know the shoulder, I can kind of picture a goniometer there. Okay, so whatever the joint is that you're isolating, put the center of the goniometer there, okay? So in a bicep curl here, right, I'm going to put the goniometer center here. I'm going to put one arm here and one arm there. So above and below whatever's moving. And I can know, like during a bicep curl, this angle at the elbow gets longer, or larger, sorry, and then shorter. So more obtuse and more acute. I know that. And so I can tell what's happening at the elbow, extension and flexion, right? If I now think about the elbow or the shoulder for the external rotation example exercise, again, if I just isolate it, yeah, my elbow moves away from my body, but it's just because my lat's here, right? And, you know, I can't go any farther. That's full range of motion for external rotation at the shoulder. It's not that far. It's only 45 degrees, right? That's it, okay? So, yeah, it might look like I'm not going all the way, but if I just go all the way behind me, I'm actually allowing other parts of my body to move. So pure external rotation at the shoulder, 45 degrees. That's as far as I need to go. Okay. So now that I know that is going internal and external, you got to think about the muscles. What muscles are doing this? Well, it's still my internal, let's say internal rotators, external rotators. So more specifically, you know, you can go infraspinatus and teres minor for external rotation. And it's just at the shoulder, right? Again, if you get more movement on that external rotation, yeah, now that's rear delt, rhomboids, any of the scapular muscles that move the scapula, the trap, you know, that's connected to the whole shoulder girdle complex. But so still those muscles working, but the question wasn't necessarily differentiating between larger and smaller muscle groups that might be doing the work, although it's not incorrect that if you have a heavier weight, that larger muscle groups won't get recruited to also do the work. That is one of the reasons that many of you identified correctly, that why you want to stay a bit lighter, focus on form. But ultimately, it's talking about effectiveness. So what is the effectiveness of this exercise? And again, if you think back to your lab, what do you have to do in your chart to figure out what's effective and not? And again, some of you even figured out, okay, well, what's actually working here? Maybe you tried it yourself, put something heavy in your hand, tried to do some of these, you're like, well, you know, my shoulder's not, and maybe internal rotators and pec and stuff like that, shoulder, front of the shoulder, the delt, anterior delt, that's not getting tired. Neither is my external rotators, you know, like this isn't very hard for them. What is getting tired is my bicep. And so again, a lot of you kind of made that connection. The bicep is doing more work. So this is where I really want to get started as far as learning from what was in the lab to applying the real reason why this exercise is ineffective. Okay, so the real reason again is I'll try to do a decent stick figure here, but we'll see. So we're just gonna look at the arm being out. So again, this is our person, that's an elbow, this is the dumbbell at the hand, okay? So let's think about, where's gravity coming from? Well, we know gravity is pointing down in this particular person's orientation because they're standing up and down, right? Maybe I'll do the rest of the person just for now. That's supposed to be their head, body, here's some legs, okay? So standing up, weight's coming down. So the resistance on that weight, that's how weights get weight, is gravity. There's something heavy. So we actually get the resistance here. So how do you keep this weight from falling down? Well, you hold it up. Well, what do we hold it up with? Hold it up with your bicep, right? And your bicep connects here. Now, a lot of you correctly identified that whether it's turned outward like this or inward like this. Right? Again, no angle has changed here. 90 degrees, 90 degrees, either direction, right? Whichever way it goes. A lot of you, this is isometric, right? For the bicep. So there's no change in joint angle at the elbow. But we do know from the picture that the weight moves. It goes from in front of us to beside us, right? So what's going on? Again, that was the shoulder moving, internal, external rotation. So, again, as we're talking about and trying to figure out exactly why this is ineffective for the external rotators. Effectiveness on the external rotators. So we know from our line of pull that that generates weight. So what is happening when the arm goes back and forth for the external rotators here? What is it externally rotating against? Nothing, because the weight is this way. So we're literally going through air when we move out, externally rotate. Okay, so when we're trying to work the external rotators, and we go against air as we rotate that elbow out, it's air resistance, and maybe momentum. Okay, so those two things, momentum and air resistance, is what we're working against. Those are very small, relatively speaking, to gravity and the weight of the weight. Okay, because again, the muscles aren't necessarily, other than momentum, affected by the weight of the dumbbell at all in an external rotation here. The bicep's working real hard to stay in the same position against the weight of the weight. Okay. Good, so we're there. So we've established no movement at the elbow, isometric bicep contraction. Now, the internal and external rotators are working, but it's just through nothing. This is the resistance. I can hold this, I'm gonna hold this, I can hold a 20 kilogram kettlebell if my bicep can hold that long enough, and my internal and external rotators aren't really doing much work. They're doing some, not none, but not that much. But the idea is, okay, to make it more effective for external rotators, what do we need to do? Well, we need to change one of two things. And this is where most all of you were able to understand or see from web resources that you looked up or something, what a better modified external rotator exercise would be. But here's why. Okay, so the reason for this is this, the line of pull. So a few of you managed to connect this dot. Okay, the line of pull and the orientation of the body and the weight to gravity is going to increase the work for the external rotators. So the most common modifications right from here, there's two. One was changing the equipment, which effectively changed the line of pull, or changing the body orientation, which changed the line of pull. And you should notice that this resistance, or the movement of the weight, ran perpendicular, so at 90 degrees to where gravity was going. Okay, so this was the movement of the weight, and this is gravity going straight down, right? So it made it ineffective for the weight to have any weight, okay? All right. So, changes in green. One of the things that most of you did, let's say about half of you did, is change the weight. So instead of being weight, we put a band, a cable, something. So what that did is now gravity will work, you essentially change where the resistance is. So this is a different way of saying resistance, gravity on the weight. Okay? So by changing this into a band, which provides resistance this way, or a cable, sorry, I guess it would be this way, away from the body. So if there's resistance now away from that person's body, when they go into external rotation, this is X, okay, they have to work against that resistance. So now the resistance and the line of pull that the external rotators, these guys the external rotators here up in the shoulder, which work on rotation at the shoulder joint. You see that? Oh, yeah, you can kind of see that. So rotation way up at the shoulder joint, right? Now that's running the same way. Line of pull, resistance. The other thing you did, some of you did, was took your body from here and turned it sideways, okay? So instead of being upright, now we're going to put the person, let's see this, sideways, okay? Okay, so same person, just turn sideways. That's all, same thing. Their external rotation is still going to happen in this way, okay? But now what's happening? Well, now gravity is down. Oops, sorry, I'm switching colors here. So gravity is still coming down. The external rotation, the weight, is going this way, externally rotating. But now the line of pull is now in line with gravity. Okay, so now you're going, here's gravity, here's your line of pull as the weight's coming up and down. Okay, so now those are running parallel. Okay, because the weight, again, if I was to draw this line, because again, this is the weight generated off the weight. The weight's going to be here, right? So that's gravity. Here's your line of pull. So now everything's parallel again. So essentially, in order to make an exercise more effective, you need to ensure that the line of pull is not perpendicular to the muscles that you're trying to work and isolate most. Okay? Wherever you have parallel, so up in here, our parallel line of resistance is for the bicep. So that gets the most work. Whereas in this position, the line of pull is for the external rotators, trying to rotate up against gravity's down. Okay? So hopefully, again, that will explain things a little bit. I hope that's shown up on the video. I hope you can zoom in, make it big enough. I'll maybe just take a photo of this as a whole completed, throw it up online so you can actually see at least the end result of what I'm doing as I'm kind of drawing it and saying the words. And hopefully that'll help you understand. Because again, if you understand how to figure out where the line of pull is on an exercise, you should know how effective that exercise is. Okay? Okay. Hopefully that helped. If there's enough of you that need a little tutorial and need some help on this, I'll run through this again in a bit of a live tutorial web workshop. We'll post the video after for those that can't make it. But again, I can try to get a little closer view shot of the whiteboard as well. Okay. But again, so this is why. This is ultimately the answer that I was looking for in a lot of discussions, or at least to have people get to eventually. Okay. So yeah, great. So hopefully with those two concepts from last week discussed a little bit farther, that'll kind of help most of you have a better understanding of that for when things like this comes up again a bit farther down the road in other labs and on your final. Okay. All right. Great stuff. I'm looking forward to seeing everyone's presentations this week, and there'll be more information on the post that I made yesterday, which is on the announcement for the transitions of the weeks. Okay, great. I really appreciate, again, all of you that have reached out with questions when you've had them. I'm sorry if I've been haven't just given you the answer. I typically feel that hinders learning sometimes. So if you ask questions, be expected to be asked questions back, and I'll leave little breadcrumbs for you to try to help you link all the pieces of information together to get you to the answer. Okay. If you know, it's typically uncommon that I'll just give you an answer if you ask me a question about a question. Okay. And again, I just want to help encourage the learning process and help you see that probably the whole time you had all the information you needed. You just needed to kind of see it in a slightly different way. Okay. Okay. Keep up the great discussions. Looking forward to seeing them improved in the coming weeks. And looking forward to seeing your major assignments. Okay, take care.